Hi everyone, this is the first lab video of 2 lab videos this week. You have 2 labs. This is the only week where you will have 2 labs, so I will just be going over Lab 1 supplement for this video. And I just want to point out where your Lab 1 supplement is located. So you will begin by downloading either the lab supplement in Word format or the lab supplement in PDF format. So I just wanted to show you where it is located before we continue. So go ahead and download either it in PDF format or in Word format. All right. So this is what it looks like when you open up that document. It looks like this, Lab 1 Supplement 1. So it goes into, again, we're going to look at scientific inquiry, the metric system, measuring, and graphing, okay? So you might think, okay, well, this is an online course. Why do I need to know how to measure things? Well, you will be measuring things because, again, you're going to be filling out that lab waiver if you haven't done so already, and including on that lab waiver, you're going to be putting in your address, and so you're going to be shipped a lab kit. So that mini lab kit is going to be containing some measuring devices and some tools for labs that you can perform at home. So you will be using some lab equipment in your home to perform some of the labs that we'll be doing throughout the term. And so this Lab 1 supplement will get us used to using, to measuring things. So we're going to be getting into a little bit about the scientific method. We'll also learn about the metric system. So the metric system is something that we're going to be examining throughout the term. So we'll learn how to convert things from like centimeters to meters and kilometers to I don't know, kilograms, something like that, okay? Or we can't do meters to grams, but kilometers to like centimeters or something like that, okay? So we'll learn about that. We'll also learn how to measure things. So we have our different units: length, mass, volume, and temperature. So we'll learn how to do that using the metric system. And then finally, we'll learn how to graph data, okay? So that's all in the lab supplement. So in the first exercise in your lab supplement, exercise 1.1 is the scientific method. So it'll give you a link to this Study Jams video, okay? So you'll basically just open it up and then you'll play the video. So as you play the video, it'll walk you through the scientific method with this activity with the hummingbirds, okay? So it'll walk you through and show you, the different steps of the scientific method, from making observations, what is a hypothesis, how to design experiments, collecting data, and drawing conclusions. Okay, so you'll just basically need to play the video, but you can also, explore further if you'd like. Okay, and you can even explore even further if you want to, but that's not required. Okay. So once you're done watching the video, then there are a few questions that you're going to be answering on your lab supplement based on the video. Okay, so you just answer those questions. Okay, so that's it for exercise 1.1. So that's pretty simple. The next part, exercise 1.2, goes into the metric system. So the metric system can be confusing at first because we're so used to just, the English American system of measuring. So we're used to, miles instead of kilometers, and we're used to pounds instead of grams and kilograms. So we have to start getting used to the metric system because science uses the metric system. If you're going into health sciences, like most of you are, when you're dealing with patients, basically when you're measuring things out for your patients, it'll be in units from the metric system, okay? It'll be grams, it'll be milliliters. It'll, it's not going to be the units you're used to. So we'll get used to it together in this course. So luckily the metric system is a base 10 scale. So once you get a hang of it, it's actually fairly easy. You just have to, remember it's base 10. Whereas if you think about it, our scale is a lot more confusing because it's kind of just random. Like, the way that we convert things is very strange. Like we have 4 cups in a quart, and I don't know how many, like 4 quarts in a gallon, and then we have like 12 inches in a foot and 3 feet in a yard. But in the metric systems, everything's by tens. It's a base 10 scale. So we start with this base unit, and then everything is by 10. So if we go up, to 10 by 10, then, we just move up 1. So if we go 10 to the first power, that's, 10, then the prefix would be deca. If we go 10 to the second power, that would be 100, then it would be hecto. If we go 10 to the third power, that would be 1,000, it would be kilo. So we're just basically multiplying everything by the power of 10. Okay, so it's a logarithmic 10 scale. So the units that we need to know for this particular course, and which will be most common in like the health sciences, is the prefix kilo, centi, milli, micro, and then sometimes you might actually see nano, so I'm going to write that one in there just in case. Nano means the symbol is an N. And instead of having 5 zeros in front, it's 1, 2, 3, 4, 5, 6, 7, 8, 1. So that's 10 to the minus 9. Okay. All right. So let's take a look at these. Okay. So kilo means 1,000. So if I'm talking about a kilogram, so kilogram, kilo means 1,000. So that means that 1 kilogram is equivalent to 1,000 grams, or 10 to the third power. Okay. 1 kilometer is equal to 1,000 meters. 1 kiloliter, okay, is equivalent to 1,000 liters. All right, so our base unit, if you notice here, we have 3 types of base units. We have grams, meters, and liters. Okay, so those are the 3 types that we use for measuring things. If we're measuring weight, it would be grams. If we're measuring length, we would be using meters. And if we're measuring volume, it would be liters. So, so if I'm measuring something large, I might measure it in kiloliters or kilograms or kilometers. Okay, so 1 kilometer equals 1,000 meters. Okay, so if I ran a 3K, that's 3,000 meters long, right? All right. If I go the opposite direction, I get smaller. So if I'm less than a meter, I can measure things in centimeters, millimeters, micrometers, or nanometers, okay? Or same with grams, okay? So centigrams or centimeters or centiliters, that is 10 to the minus 2. So that basically means that I would have to the 100th in my decimal point, okay? So this means that if I have 100 centimeters in 1 meter, okay? Or if I want to measure it the opposite, 1 centimeter equals 0.01 meters. Okay, same thing. So 100 centimeters equals 1 meter, or 0.01 meters equals 1 centimeter. Okay. Milli is another prefix. Okay, so milli, you can see the symbol is an M. So that's milli, think 1,000th. So centi is 100th, milli is 1,000th. So 0.001 or 10 to the minus 3. So milligram is 0.001 grams, or you can think of it as 1,000 milligrams, or are in 1 gram. Okay. Micro, since we've already used the symbol M, I can't use M for micro. So I have this weird U shape. Okay, so this is like a little Greek symbol U. So micro is 10 to the minus 6. So you can see here it's 0.000001. So 5 zeros and a 1. So otherwise I can think of, it's 10 to the minus 6, or it would be, basically if I have 1000, it's 100,000 micrometers in 1 meter, or 0.000001 meters in 1 micrometer. Okay, and then nano is N. So, and there it's basically 10 to the minus 9. So I could have 1 million nanometers in a meter, or I could have 8 zeros and a 1 nanometers, or meters in a nanometer, okay, or 10 to the minus 9. Okay, so these are the different prefixes, all right? So you'll need to memorize these, okay? So kilo, sometimes some people just memorize like kilo is 10 to the 3rd, and centi is 10 to the minus 2, milli is 10 to the minus 3, micro is 10 to the minus 6, nano is 10 to the minus 9, okay? So some people just memorize it that way. If it's easier, sometimes people think, okay, kilo is 1,000, centi, think, century, 100, milli, that sounds like a million, or 1,000, I don't know how you remember it, micro, something like that. So kind of think of ways to remember things, all right? Actually think, mil in Spanish is 1,000, okay? All right, so once you have this down really well, then we can start making conversions, okay? So a conversion is where we can convert like one unit to another. So we can take meters to centimeters, for example. And there's a couple of ways to do that. Your supplement has one way, which has these circles, which I never understood. The other way is the ladder way. So I like the ladder way just because it's easier for me. So the ladder way starts with the base. So the base, remember the base is your grams, your meters, or your liters. Okay, so that's your base units. And then remember kilo up here is 10 to the 3rd power. Centi is 10 to the minus 2, milli is 10 to the minus 3, and micro is 10 to the minus 6. So the way you work this ladder is if you're going up the ladder, you're moving the decimal point to the left, however many steps. If you're going down the ladder, you're moving the decimal point however many steps to the right. So let me give you an example. Let's do number 1 together. So it says 1 meter, and we're going to centimeters. Okay, so if I were to draw the decimal point for 1 meter, it'd be right here, right? So I need to figure out, okay, so 1 meter to centimeters. So here's the base is meter, right? So I'm here, and I need to go here. So I'm going down the ladder. So since I'm going down the ladder, I'm moving this decimal point to the right. And how many steps am I moving it? I'm moving it 1, 2 steps to the right. So I'm going to move it 1 and 2 steps to the right. So then so here's the decimal point, and then I just have to fill in the zeros. So now I have 100 centimeters. Okay, so 1 meter equals 100 centimeters. So I've taken the base, moved the decimal point to the right 2 spots, since I've moved down the ladder 2 spots. Okay. Here's another example. We have 1 kilogram, I'm moving it to gram. So here's kilo up here, and I need to move it here. So I'm going to move the decimal point to the right because I'm moving down. I'm moving at 1, 2, 3 spots. So here's my decimal point. I'm moving it 3 spots. 1, 2, 3. So now I have to put in the zeros. So 1 kilogram equals 1,000 grams. Okay. So you can keep doing this. Let's do number 4 together. So 120 millimeters to centimeters. So millis down here, centi is here. So I'm going to move up this time 1 spot. So here's my decimal point. Since I'm moving up, I'm going to move it, the decimal point, 1 spot to the left. Yep. So now we have, since I'm moving it 1 spot to the left, we have 12 centimeters equals 120 millimeters. Okay. Let's do this one. 1,100 liters to kiloliters. So here's my base liter. How many kiloliters would it be? So I'm going 1, 2, 3 kiloliters, or 3 steps. So I'm going to the left. Since I'm moving up, I'm moving to the left 3 spots. Here's my decimal point. 1, 2, 3. 1.1. All right. So you can just keep doing this all the way through the activity. There's a whole bunch of them. As far as what you're going to be submitting for points, I'm only grading this side. Okay, so that's why I'm working over here a lot. But you know, once you get the hang of it, it gets pretty easy. So like 8 grams to milligrams. So here to here, so that's 1, 2, 3 down, 8. So then, you know, I kind of already know it's going to be 8,000. Okay, I can move pretty quickly. 3 liters to centiliter, you know, that's 800 or 300. Okay, so you can kind of move fast after a while. So that's, I can tell right now, that's 50 because that's 10 to the minus 2, that's 10 to the minus 3. So I'm going to add 1 0. So you can, you know, continue practicing as you go through. All right. So there's a whole bunch of them. So again, you know, just try your best. You can use this as a helper. There's another helper there's circles at the top, which I could never figure out, but if that's easier for you, you can do that as well. Okay. All right. And then moving on, in exercise 1.3, you're going to be practicing measuring things. Okay, so the first activity, you're going to be measuring the length. So you'll need to have some sort of ruler with centimeters to measure. Okay, so it could be any type of ruler. It could be, you know, a small ruler that maybe you had, like, you know, in high school or whatever. And you can, you know, you have an OpenStax textbook, which is an online textbook, but just grab any book. It doesn't have to be a textbook or, you know, a biology book. It could be anything. And you're just practicing measuring it. So you want, you know, the length, the width, and the depth of it. Okay, so all in centimeters. Okay, so you're just practicing measuring things with the centimeter side of it. Grab a coin, a dime, and measure the diameter of it in millimeters. Okay, so you're just practicing using a different unit of measurement on your ruler. Okay, so instead of the centimeter, use the millimeters. Measure your foot. Okay, so if you have a small ruler, it might you might have to guess at it, but you're going to measure it in centimeters. Okay. Measure your desk at home, or if you don't have a desk, a table or something like that. So this time try to measure it in meters. So, you know, this might be hard if you have a little tiny ruler. So you could use, like, if you have a measuring tape, it might be hard because a lot of the measuring tapes are in inches. So what you could do is you can measure it in inches and then convert it. Okay, so you might have to, like, go to Google and figure out how many inches are, or how many centimeters are in an inch. I think it's like 2.54 centimeters are in an inch. So then from there you have the number of centimeters, and then you can convert that to meters, okay? And then get the meters. So you want the height, the width, and then the depth of your desk. And then figure out, same if you have measuring tape, measure your height. So again, if your measuring tape doesn't have centimeters, try to just convert it from inches. Okay, so use, convert the 1 inch equals 2.54 centimeters, and convert that to centimeters. All right. So that's pretty simple. You can do that at home with any ruler or measuring tape device. Even if you don't have the metric system, you can do conversions from inches, okay? For the measuring of weight, you're gonna watch a video. This is a YouTube video that was done by, I think it was, let me see, I'm pretty sure this is Jen doing it. Yeah, Jennifer Brown, she's the one who you'll see a lot in these videos. So she, so she's like the person that developed the course. So you'll see a lot of her in these videos, or you'll hear her voice a lot in the YouTube videos. So you'll watch her practice using an electronic balance, and so you'll see how she measures things with an electronic balance, and you'll see her use what's called a boat. So just watch that. If you have an electronic balance at home, which is basically just like a scale, like a kitchen scale, if you ever measure things in the kitchen using a scale in your kitchen, you can just whip that out and practice using it. I wouldn't use like a scale that you use to weigh yourself, because those are usually, they're not designed to measure something as minute as the weight of a coin. But think, if you do have like a kitchen balance, a kitchen scale, try to use that if you have one. If not, don't worry, you don't have to practice measuring that, okay? But these are some things that you can practice measuring if you have one available. So if you have a scale at home, a kitchen scale, practice measuring, grab a coin and measure that. And even those kitchen scales at home, you can convert the unit to grams, okay? So you can measure it in grams, okay? For the sugar, okay, obviously you're not going to dump a 1/4 cup of sugar onto your scale. So what do? You need to tare it. So you need to, take a measuring cup that's empty, put it on the scale, press the button, usually it's the on button, and it zeroes it out. So that's what tearing is, it's zeroing it out. And then you add the 1/4 cup of sugar, and so you're just measuring the weight of the sugar, not the weight of the sugar plus the measuring cup. Okay, so you can practice measuring that way. All right. And then next we have measuring volume. So first we need to figure out what is what here. So in your manual you have three, this is actually from your supplement. So we have 3 items here. So one of these, we have what's called a beaker, a graduated cylinder, and an Erlenmeyer flask. So we have to figure out which one is which, okay? So this here is what we call a graduated cylinder. So one way that you can remember graduated cylinder, remember those little caps that you wear when you graduate from high school? It kind of looks like this down here, right? So think of that as like a graduated cylinder. You got the graduation little cap down there, okay? So that's there to measure something that is more accurate, okay? Here we have a beaker. So beakers, you can measure larger volumes of things. And then this is called an Erlenmeyer flask or an E-flask. Okay, so this is also used to measure volume. So you're going to watch a video. So this is another YouTube video from Jennifer Brown. And so she's going to have some different glassware, and you're going to learn about the different types. Okay. And then, so she'll walk you through the different types, and look, there's the graduated cylinders. Okay. And then you'll learn how to measure things. Okay. So in your lab supplement, you'll notice, because of one of the properties of water that we learned about this week, is that water has cohesive forces and adhesive forces. So, you know, cohesion means that water likes to cling to each other, and adhesion means that it likes to cling to other nonpolar substances. And because of that, it clings to each other, and it clings to the sides of the graduated cylinder. And so it creates this little meniscus. And so when we're measuring a liquid, where do we measure? Do we measure at the top of the meniscus or at the bottom of the meniscus? Well, we measure at the bottom of the meniscus. Okay, so we don't measure where it's clinging to the side, we measure at the bottom of the meniscus. So if you're looking at this particular graduated cylinder here, this measurement, we're measuring right here. Okay, so this is between 20 and 30. So this would be 25. So it looks like this is 24 milliliters. Okay. This would be between 2 and 3, so you can figure out what that one is. Okay, I won't tell you the answer, but this one's definitely 24. Okay, 24, I think this is milliliters. You have to look in your book. All right. And another way that we can measure things in more minute details is with a pipette. So measuring with pipettes are a little different. So you can see here we have, we still measure with the meniscus, so you still see at the bottom of the meniscus here. But you can see the volume is a lot smaller here. So we're you know, looking at individual units. So this is, you know, 1 milliliter instead of, you know, 20 to 30 like we saw in the others. But you can see here the length of the pipette. This goes from 0 to 10. So the full 10 milliliters would be if I went all the way to the tip. So that's the full distance here. So if I suck up the liquid, I would want to suck it up to the 10 meter or to the 0 mark, and then push all that liquid out if I wanted the full 10 milliliters. Okay, so that's a little different in measuring things. Okay, and then you can, you know, describe the pipette, try to, you know, figure out what it's measuring and so forth, and then answer the questions. And then finally we get to measuring the different temperatures. So in the metric system we use Celsius instead of Fahrenheit. So here's the conversion of how we convert things to Celsius. So you can see we take the Fahrenheit temperature, subtract 32 degrees from it, and then we multiply that times 5 divided by 9. Okay? So what you're going to do is you can actually just take the temperature of wherever you are. If you have a thermometer, like if you have like an outside thermometer sitting outside, you can just take the outside temperature. Or if you have like a weather app, you can just take it there and figure out what the outside temperature is. If you don't have that, then you can just use these, okay? So pretend this is, I don't know, the inside temperature and that's the outside, or vice versa. But we're just practicing measuring, okay? And then you're going to figure out what is the boiling temperature and the freezing temperature in Celsius. It's really easy if you don't know off the top of your head. And then what's the human body temperature in Celsius? Okay, so you know in Fahrenheit it's what, 98.6 degrees or something like that. So what is it in Celsius? So you're just going to do those conversions, all right? So if you don't have the inside temperature, by the way, just use, if you can go just look at a weather app, figure out what it is in Fahrenheit, and then just convert it for the outside temperature to Celsius. You don't have to do room temperature. Okay, all right. And then the last activity gets into graphing. So it's important for us to, once we've run experiments, we collect data, and then we have to make sense of the data, because usually it's just a bunch of numbers and it's like, well, I don't know what the numbers mean. So we have to kind of make sense of it by graphing. And so graphing is a way that we can visualize the data and interpret it. Okay. And the way that we graph things, we look at the variables, and then we look at the patterns that we see in the data. So the way that we set up a graph is, well, based on the scientific method, we learned that there's different variables, which are basically things that change in the experiment. So we decide ahead of time what the independent variable is. So the independent variable is the manipulating variable. So that independent variable always goes on the x-axis. Okay, so that's the horizontal axis. The variable that we're going to measure, that's the dependent variable. Okay, so that's the responding variable. So that always goes on the y-axis. So an easy way to remember that is the acronym DRY MIX. Okay, so DRY MIX stands for dependent or responding variable goes on the y-axis, manipulating or independent variable goes on the x-axis. Okay, so that's just an easy way to remember which goes where. Okay, so the dependent variable or the responding variable always goes on the y-axis, the vertical axis, and then the manipulating or independent variable always goes on the x-axis. So once you've labeled your axes with your dependent variable on the y and your independent on the x, then you have to figure out what type of graph are you going to do. Are you going to do a line graph or a bar graph? Okay. That's generally the two types of graphs that we use. Well, the way we determine that is based on the type of data we have. If the data that we have is continuous, meaning that we can connect the dots between the values, then it's going to be a line graph. If we cannot connect the dots between the values, it's considered a bar graph. Okay. So a continuous variable means that there's unlimited numbers between the values. So for example, if my independent variable is time, well, time is continuous, right? If I'm measuring, if I'm measuring like the growth rate of my plants over several weeks, the week, the time is the independent variable, and then the growth rate is the dependent variable, and both of those are continuous variables because the time is continuous because, if I go from week 1 to week 2, there's unlimited possibilities in between, right? Time does not stop. And then on the y-axis, the growth rate, it's continuous, right? So the plant doesn't stop growing. It continues to grow throughout the weeks. So that would indicate that I would make a line graph. An example of a discrete variable would be if, for example, I have two data points that cannot be connected. So for example, let's say that I was taking a poll of the people that were voting for the two different presidential candidates. Okay, so we have the Republican presidential candidate versus the Democratic presidential candidate. Well, there's only two choices. Okay, there's no in between. There's no like half Republican, half Democrat president possibility. There's only these two candidates. Okay, so I can't connect the dots there. Okay, so that would be an example of a discrete variable. There's no in between. There's no partial presidential candidate that they could vote for. There's only two people on the ballot. You either choose this one or this one. Okay. And so that means that there's a limited number of possibilities. So that would be a bar graph. So, you know, how many voted for this one, how many would vote for that one, and then you get that bar graph, okay? So that would be an example of a discrete variable, okay? Another example would be like if you took a poll on like the number, you know, what type of pets you have at home. So, you know, people might say that they have, you know, cats or dogs or fish or guinea pigs or bearded dragons. But you can't have like an in between a bearded dragon and a fish. You can't have a bunny dragon or something like that. There's no like bunny dragon hybrids, right? So that's not possible, or, you know, a cat dragon or something like that. So that would be an example of a discrete variable. Okay, so continuous variables, you can have an unlimited number of values in between the points, so you can connect the dots. Discrete variables, you cannot connect the dots. No bunny dragons exist, so no connecting the dots allowed. All right. So this is directly from your supplement. So when you are graphing something, always a good idea to have graph paper. Since you're in an online course, you could potentially do an Excel spreadsheet if that's easier for you and just make a graph through there. But, you know, if you don't know how to do that, then just do it the old-fashioned way. And so there's always graph paper in your lab notebook or your lab manual. So you can do it freehand. In the lab supplement that we gave you, there's graph paper as well. So use graph paper to plot the values accurately. So don't just use like line paper. So the graph paper is going to make it nice and pretty for you. You'll need to include a title. So the title includes a summary of what it shows. So always a good idea to include the dependent variable in the independent variable when you include a title. Okay, so that summarizes what you're showing there. Your axes, make sure you label your axes with the independent and dependent variables, as well as show the intervals of the units of measurement. Make sure your intervals are even, okay? So you can't go like on the x-axis, go 2, 5, 9, 23, 59, okay? That's not an accurate range. You have to have an even range, you know, 5, 10, 15, 20, 25, 30 for each of the intervals. So it has to be of a constant amount. Sometimes you need to have multiple graphs, so that means that you have 2 or more data sets in a single graph. So if you have like, you know, multiple lines, like 3 lines or 3 bars on a single graph, you might have to use a legend to indicate, you know, what each line indicates. Okay. So let's do an example. So this is the third graph on your page. I think it's page 20 or something like that in your lab supplement. I can't remember. Or page 13, excuse me. So here we have our, we're going to look at the flavors. Okay, so we have, this is the flavor and this is the percent of total sales. So first of all, which one is the independent variable and which one is the dependent variable? Which one did we decide ahead of time? And then which one is the measuring one? So this one we decided ahead of time. This is what we ended up measuring. Okay, so this is the independent variable and this is the dependent variable. And then remember dry mix. Oops, sorry, that's a D. I'm writing with a mouse, it's very hard. Dry mix. Okay, so dependent or responding variable goes on the y-axis, manipulating or independent variable goes on the x. Okay, so I'm going to try to draw with my mouse, it's going to be hard, my graph here. Okay, so here's my x-axis. Down here, this is going to be my flavors. Sorry. And then over here is my percent sold. Sorry, it's really hard to do that. Okay. And then For my percent sold, you know, it goes up to 35%. So maybe I'll do like, I don't know, 5%, 10%, 20%, or 15%, 20%, 25%, 30%, and 35%. Okay. And then I need a title, so my title could be flavor of ice cream, or flavor. It's really hard writing with amount of ice cream. I'll just do IC for ice cream versus percent sold. Something like that, okay? And then I have my flavors. So I'm just gonna abbreviate because it's hard to do this with a mouse. So I'm gonna have vanilla, I'm gonna have chocolate, I'm gonna have Napoleon, chocolate chips, and strawberry, and then the other, okay? So then I gotta figure out, is this gonna be a line graph or a bar graph? Can I connect the dots between vanilla and chocolate? Nope, so this is gonna be a bar graph. So vanilla, so that's going to be 12.4, so that's going to be right about here. Okay, so I'm going to do a bar graph. Okay, so it'll look something like that. Chocolate, 35.1, way up here. Okay. Oops, I kind of did that weird. It should be over here. Okay, your graph will be nicer than mine because you're not doing this with a mouse. You're doing this hand-drawn, so it'll look nicer. Napoleon 5.6, so that's, I don't know, right around here. Chocolate chip 5.9, it's probably a little bit more. Oops, probably a little bit more. And then strawberry 7.4, so that's right about there. And then others 33 something. Okay, so basically from this graph, we can tell what's the clear winner here. So it looks like most people chose chocolate or other, right? So those were the top winners. Vanilla was a distant third. So based on just, you know, it's a lot easier just to see from the graph that chocolate was the clear winner and other was a clear winner. Vanilla was a distant third, and then these guys, you know, were kind of lumped together. All right, so that's how you're going to graph something. Pretty simple. All right. So once you have completed your lab topic supplement, you can go ahead and submit all of the pages if you'd like, if you typed them up, or if you printed them out and wrote everything by hand. You can go ahead and just turn in the pages that you wrote on. So, you know, you can just turn in the pages that you actually have your handwriting on. If you did do it by hand, I highly recommend that you use Adobe Scan. Adobe Scan is it's a free app that you can use for your cell phone, and basically what you do is you just open the app and have the pages in front of you, and you just take pictures of the pages. And what it does is it just compiles it into a single PDF for you, and then you can submit it that way. Okay, so again, you can just submit just the pages that have your own writing in it, or you can submit all of the pages if you'd like. So when you submit your pages, it needs to be either in Word or PDF format. So Hike or Pages or any other file format will not be accepted. I simply can't open them on my end. Okay, so you'll be asked to resend them. Okay, when you're ready to send them, you will go ahead and go to this Lab Topic 1 Scientific Inquiry place, and yours will look different because you're in student mode, but it'll have you upload in either Word or PDF file format, and you'll just go ahead and submit there. Okay? If you have any questions, feel free to reach out. Otherwise, you'll submit this by Sunday midnight.